We're going to have a look at them now. All right, let's see. We have got question 1, and it says the diagram below represents a process involving DNA. Okay, so clearly it's exactly aligned to our joke that we've just seen, because what's happening? We've got the DNA opening up because it's getting a massage and the backbone is relaxing. All right, what have we got? They've given you A's for adenine, G for guanine, T for thymine, and C for cytosine. People, remember, you always have A to T and G to C. These are your purines, and these are your pyrimidines. Okay, now your pyrimidines have a Y, thymine has a Y, cytosine has a Y. So Y, and pyrimidines. And purines, pure as gold. So purines are adenine and guanine. Your adenines will, adenine will always bond with thymine, and guanine will always bond with cytosine. These are our base pairs. And I think I said it about 30 times last week. I'm telling you again, you can't forget this. Any question you have on DNA, A equals T and G equals C. You make sure you know that off by heart. All right, so let's go. We've got our DNA that's opened up. So clearly what we're looking at here is DNA replication. Okay, now if that's adenine, that's going to be thymine. If that's thymine, that is adenine. So guanine, cytosine, cytosine, guanine, thymine, adenine, guanine, cytosine. Come, I want you to do this with me. Okay, now here, remember we've got this DNA that's now opened up because of helicase. All right, so this is going to be our original, this is going to be our original, and this is going to be the new strand. And the new strand is made up of these nitrogenous, at least nucleotides, that float around freely within the nucleoplasm. Okay, so they're DNA nucleotides and they're just floating around. And when that DNA strand opens up, and we've got the 2 strands, each strand is going to make a template, and they're going to have complementary bases that come in to join them like that. Okay, so what do we have at all of this now? So if this is G and C and G, then this one is going to be G and this one is going to be C. And if this is T and A, then this will be A because that is T. This one will be C and this one will therefore be G. So that when you've finished, this new strand here is going to be identical to this one. It's going to have one old and a new, and this new one will be the same as the old one there. Okay, there we go. Let's look at our questions. Identify the process illustrated. Well, that's easy. It is DNA replication. We are copying the DNA. Now, people remember, DNA replication happens during interphase, before mitosis and before meiosis. Okay, it is when the DNA literally duplicates itself. It makes an identical copy. All right, that's DNA replication. It is making a new one. Identify monomer X. Well, that's easy. Monomer X here is a nucleotide. Now remember, we spoke about in the joke, we have a phosphate, then you have your pentose sugar, which is a 5-carbon sugar. In this case, it's going to be a deoxyribose sugar. And then attached to that, you're going to have your nitrogenous base. And then phosphate, pentose sugar. And so this is what forms the backbone. All right, that's the backbone we were talking about. So here, it's a nucleotide. Phosphate, pentose sugar, nitrogenous base. Using the key provided, give the names for 1 and 2 respectively. I can't remember which was which. 1 is guanine and 2 is cytosine. So 1 guanine and 2 is cytosine. People, they've given you the spelling. So don't go and misspell these words. You've got the spelling right there. Right, then what is the natural shape of the molecule that's represented? Well, DNA is always a double helix. Okay, helix means it is twisted. It's twisted around. And there are 2 strands. If you remember our joke from last week, you had DNA with the 2 strands saying to RNA, are you still single? All right, so single strand for RNA, double strand for DNA. Then it says, name the bond that forms between 1 and 2. I can tell you already, they are weak hydrogen bonds. Okay, they're weak hydrogen bonds, so they can break easily. And then tabulate 3 differences between DNA and RNA. Now remember, whenever they say tabulate, you must make sure that you draw a physical table. Okay, so you have to physically draw that table. You write DNA here and you write RNA here. People, you must know the comparison between the 2, all right? So, and also, whenever you do a table, compare apples with apples. So compare the same thing each time. So let's go. With DNA, well, the easiest one is that it's a double helix strand. Okay, so double helix strands, there are 2 of them. Here, we're going to have a single strand. Okay, that's easy. Now, next one. DNA has, and it's named after this, a deoxyribose sugar. Okay, RNA has a ribose sugar. Another very easy one to remember is DNA is in the nucleus. It's only ever in the nucleus, and RNA is in the nucleus and the cytoplasm. Okay, let's just get ourselves a little bit more space here. Okay, so there's 3 easy ones to remember, but I'm going to give you more. DNA, we have thymine base, and remember, RNA has uracil base. So RNA is going to have cytosine, guanine, adenine, and uracil. And DNA will have the same 3, but thymine instead of uracil. Okay, last one, that's also very important. Remember, in DNA, because it's a double strand, I'm just writing a double strand, okay, you are always going to have an equal number of base pairings. Okay, so let me just move this down a bit. So in other words, therefore, adenine will always equal thymine and guanine will always equal cytosine. So if I've got 10 adenines, I'm going to have 10 thymines. If I have 30 guanine, I'm going to have 30 cytosine. Whereas with RNA, the bases are in any number and ratio because it's one strand. Okay, and that's how you're going to tell the difference.